Okay, so we are going to do lesson 6A and 6B together in this video, which is of Unit 2, Powers and Roots. And lesson 6A is applying the exponent laws. So exponent laws help simplify expressions with integral exponents. These exponent laws, I'm just going to say right off the bat, they're really important, and we're going to get lots of practice in both 6A and 6B. So you will see how they go. So here's a chart where we're going to break them down. So the exponent laws note that A and B are rational or variable bases, and M and N are integral exponents. Okay, so product of powers. So product means multiplication. So I'll just give you a little reminder right there. So if we have a number A and it's to the M, and it's being multiplied by another number to the n, same number, a to the n, it will equal a to the m plus n. So when you're doing multiplication, you will add the powers together. Quotient of powers, so quotient means division. So if we have, same numbers, a to the m divided by a to the n, it will be the opposite. It will be a to the m minus n. All right. Then we're going to do power of a power. So what I mean is we have a to the m, and it is all to the n. And so here, sorry. Here, what we're going to do is we will multiply a to the m times n. Next, let me just move this up a little bit. Power of a product. So for example, we have a times b, two numbers, and then both are to the, sorry, I don't know why that keeps happening. Both are to the power m. And so what this actually equals is a to the m times b to the m. All right. Next, we have power of a quotient. So a over b to the m, which is the same thing as a to the m over b to the m. All right. And then zero exponent. So there is one, yeah, there's a star because it's a little bit tricky. So we have a to the 0, and we know that that equals 1. We have a times b to the 0 will also equal 1. If you have negative a in the bracket to the 0, that also equals 1. And then this one is different, so you got to remember negative a to the 0. Nothing's in the bracket there. This will equal negative 1. So I'm just going to underline in another color. That one is different. You have to take a look at that. It can be tricky when you're thinking about other things. Okay, so that's zero exponents. Now we are going to remember a radical can be written with rational or fraction exponents. So this is just review. So I'm going to do the first two, and then you can check the rest in the key. So root 6, sixth root of 32, everything squared, is the same as 32 to the 2 over 6, which you can simplify to 32 to the third. Third. Let me just make that a little bit. To the third. Okay. Then root x to the 7th can also be written as x to the 7 over 2. All right, try the other two. They've got some negatives in there, so take a look at where those are, all right? Okay, and here now this is where you get to practice all of the exponent laws. So use your chart while you're doing these, and we are going to do, I think, the first 4. and then you can try the rest, check the key, bring your questions to office hours or class. Okay, so starting off with A, we have x to the 5 times x squared. So just as a reminder, when you're multiplying, you will add the exponents together. So this equals x to the 7th. Next, B, we have m to the 7 divided by m cubed. So this one's the opposite dividing, so we're going to subtract. Oh my goodness, that is supposed to be the subtraction sign. Subtract. So 7 minus 3, we get m to the 4. Next, C. So we have a times b both to the 4. So we know that that equals a to the 4 times b to the 4. Okay. And then D, we have x over y squared, everything squared, which we also know means x squared over y squared. Okay, so I want you to try the rest and bring your questions. There are many more here in section 6A. And we're going to continue on with lesson B, 6B, which is applying the exponent laws, which is actually just more practice. However, we have lots of, we're going to use rational exponents. So we have the fractions and the exponents here. So same thing, I'm going to do a few, and then you will continue and do the rest and bring your questions to class. So A equals x to the 2/4 times x to the 1/4. So we remember that when we're multiplying, we add. So this will equal x to the 3/4. B, we have x to the 3/2 times x. So that looks a little tricky to begin, but I want to remind you that you can add in. So if it's just 1x, so this x is x to the 1, and the same thing as 1 would be 2/2. So x to the 2/2. So now that makes it a lot easier. So we can add them because it's multiplication. We have x, so 3 plus 2 is 5/2. All right. For C, we're dividing. So remember, we're going to subtract. Y to the 5/7 divided by y to the 2/7. We're going to do 5 minus 2, which gets us y to the 3/7. Okay, let's do D. So we have x to the 1/2 to the 2/3. Okay, so remember we're going to multiply. So what that looks like is we'll do x, and when we multiply fractions, it'd be 1 times 2. So we multiply the numerator, and then we multiply the denominator 2 times 3. So we have 2/6. And then we can simplify that, of course, to x to the 1/3. Let's make that happen this way. Okay. And we will do one more. So we have E, which is a squared over b all to the 1/2. So we are going to, it's multiplication, so we are going to take a, so the squared times 1/2, so it would be a to the 2/2. So remember, this is actually 2/1, so it would be 2 times 1, and then 1 times 2. And then over b to the 1/2. And of course, we can simplify this to a over b to the 1/2 because 2/2 is just 1. Okay, so try those out. This section is just a lot of practice. There's one word problem here at the end. And let us know how it goes. That's 6B and 6A.